Hi Fedor.
Hello.
Thank you for joining us for EtherNet IP Ring Topologies, the principles and the benefits. I'm really excited to go through this with you today. I'm very familiar with PROFINET, but I'm very curious to see what type of ring topologies you can do on EtherNet IP.
Yes, and you will learn that, well, if you're talking about PROFINET, it's pretty much the same, but still there are some differences, and we're going to talk about that.
Perfect.
So, let's start. Before we talk about redundancy for Ethernet IP, I'd like to start with some first words.
Yes.
And that's explaining that cabling in general in a network is very important. I like to call it the nerve system of your installation. And if something is wrong with the cabling in your network or the network in general, then your installation and your process is paralyzed. So that's very important to know what's happening on your cable and also to think about things how to make your network work better.
So a part of the cabling and a part of the network, fundamentally if your cabling in your network goes wrong, it doesn't matter what you have on your network or how well it's designed, it's simply not going to work.
It's not going to work, yeah, that's pretty much it. And so we can even further with these words. If we look at the cost of a network, we're talking about downtimes and failures. Initially, if we start up a project for an installation, for the installation, yes, you have the initial costs. You have the installers, you have the engineers, you have also to buy all products, all things you need to put in the installation. But those costs will decrease very fast because at the end of the project you can start producing. But then you get your maintenance costs, and those costs will increase over years. And with those maintenance costs, you have also your failure cost. The task of the maintenance engineers and, well, all the people in general is to keep those costs as low as possible. And because one of those costs is the failure, we need to keep the failures as less as possible.
Yeah, so if I'm looking at this graph here, I can see that the total cost, particularly after a number of years of operations, is basically the cost of your failures.
Yeah.
So if you can reduce the number of failures by permanent monitoring or other means, then it's going to reduce down the total cost of your network and your operations.
Yes, excellent. And if we go one further, we can also see the types of failures. If we're talking about failures, you have disturbances, you have partial breakdowns, and also your total breakdowns. Those three types of breakdowns or disturbances will cost you more or less money. Disturbances, small disturbances, can cause hiccups in the communication. But production will continue, and if you are still above your capacity, then there's no problem. And at one point during a maintenance phase, you can think about how to prevent the next disturbance. If we go a bit further, and then we have the partial breakdown, and then the production starts for a small moment, and then you're falling behind on your production, behind your capacity, so that will cost money. And at the end you have the total breakdown, so the maintenance personnel has to go into the field and have to fix the failure, and all this time you don't have any production, and that will cost more and more money.
Wow. So I see on here that you said that basically it's not a matter of if, but when there is a failure.
Yeah.
So my understanding here is that you're never going to be able to 100% prevent the downtime, but the importance is being able to identify it early and being able to fix it quickly, which you can do with monitoring solutions.
Yeah.
But then I think we're going to lead into this, that it's even better to have redundancy, so if it does fail, you have that backup system.
Yeah, and I like to go back to the monitoring part. If you have a permanent monitoring, you can also see the failure coming, and also before you have the failure, you can do your maintenance. And it's also very good, you have your predictive maintenance, and it saves money a lot.
Also, by having permanent monitoring, you can identify the problem and fix it before it brings your network down.
Yeah, exactly. So, like you said, it's not if, but when you have the failure, everything breaks down eventually.
Okay.
So, talking about redundancy, we can make redundancy in different ways. Later on, we will see some possibilities. But in general, we will work with a ring network. And this ring network is a kind of topology where all devices are combined together or connected together. So you have, well, literally a ring. And then you have also a backup path for your communication.
Oh, wow. So I'm seeing more and more of this ring topology industrial Ethernet. Is it the ring topology tends to be the most popular type that is used?
No, we have many types of topologies. For small networks, you can have the star or tree topologies, even also the line topologies. I will look into that a bit more in detail later on.
Perfect. I'm looking forward to it.
Okay, so we're already talking about redundancy. Why do we need redundancy? We want to have a backup for our communication. And also, when there's a failure in your cables, you have a backup and you can still communicate with your devices. And so you can have even a continuous production. And so we save a lot of money, we keep getting money. If you look at highways, you have different lanes. And if one lane is blocked, you can choose the other lanes and still travel across the highway.
I always remember, Fedor, when I first joined Procentec many years ago, you use the example of redundancy as like Golden Gate Bridge.
Yeah.
That you have all these cables that are not all being used to suspend the bridge, but they're there in case if any of the other cables do break, then they're to keep the bridge in place. And I do believe that redundancy in industrial networks is the same principle.
Yeah. So if one cable breaks, the cars can still travel over the bridge, and in the meantime, the cable can be fixed without any disturbances. That's a good example.
Exactly what they need in industrial Ethernet networks.
Yep. So, okay. Well, in Ethernet IP, we have also a media redundancy, and this is called the DLR, a device level ring protocol. And basically, we have again a ring. The messages will travel one way or another way. And well, there's also protocol deciding which way the message goes without going internally round and around. In the DLR protocol, we have managers and also clients. Well, we used to call them manager and clients, but we have different names for that. We can see that later on as well. And there's also a so-called beacon frame to check if all the connections are correct.
When I'm looking at this picture here, Fedor, I can see that there's tree topology, star topology, and line topology, all built around the ring network.
Yeah.
So fundamentally, the ring network or the ring topology is the backbone to ensure that there's continuous communication to those different channels or different areas of your network.
Yeah. Well, this is an example. We can have many different types of ring topologies, or also the topologies used in our installation. And so we can have use it as a backbone, but also a particular location in your installation. So, okay, talking about topologies, we can have a look at the different types of topologies. And because Ethernet IP is based on standard Ethernet, and we can have many types of topologies in our network. And that is also because it's a switch-based network. So from there we can make all kinds of connections.
Okay.
So the most common one and most known one is the star topology, where you have one switch and many devices connected to it. But there's a limitation on the amount of ports on a switch for your amount of devices in your network. But it's a simple network, and if one connection fails, and then you have connection still to the other devices. But like I said, we have limitations in the amount of ports on a switch, and so we can connect more switches, more star topologies to each other, and then you get the so-called tree topology. So we can go bigger and bigger and bigger like that. Another example is the so-called line topology, and this is something you can see a lot of times in MCC rooms, where a lot of drives are connected, well, placed just next to each other, and it's then much easier to well, connect the cable from one drive to another drive instead of connecting them to a switch.
See, that's very interesting for me to hear, because one thing that we always say at Procentec is avoid line topologies, because you have a single point of failure. But in the example you just give there, using line is okay because it's a small area, small distances, and it will be easy to manage.
Yeah, yeah. But also you have to take into account that there's a single point of failure if one of the drives that has a switch in it, because each device has a switch, fails, then every device after it, behind it, will fail also. So, well, this is a risk the end user or the engineer has to take. Okay, so from here we can also have the ring, and the ring combines everything to each other. And in this case we have a backbone structure with the line topology, the ring topology. And you can see that also in buildings where they have a ring as a backbone around the building, and from there they connect all their devices, all their other topologies to each other. And this will be the next picture. And you can see here that all the types of topologies are connected to each other. So we still have the connection everywhere.
And from what I see for the picture, the ring is basically the foundation of the rest of your network.
Yes, in this case it is. So now back to Ethernet IP. Oh, sorry, we have also this overview. You can see the different types of topologies with the benefits and challenges as well, what we just discussed. More and more wireless communication is used as well, but we will not discuss this because that's a totally different technology, and because it's not based on cable, but it's based on our air. And we can, if we want to discuss that, it will be a complete different, a new webinar.
Yeah, a new webinar. It's very interesting again for me to look at this just to see the benefits and the challenges. So what I can see from this slide is that there's no correct or right topology.
Yes.
It's just whatever suits your operations and what works best for you.
Yeah. And also taking the risk in account, for instance, the line topology. But for the same, you have the star or tree topology. When you have a switch that fails, then you lose all your communication as well. So in general, switches are most important parts of your network.
Just on that one, saying that, Fedor, so we definitely recommend that you use managed switches in all topologies, just for the amount of information it gives you about the ring itself and your network itself.
Yeah, and together with permanent monitoring, you can see problems coming before it's really giving you a failure.
Oh, wonderful.
So let's go to Ethernet IP then. Device level ring. And within a device level ring topology, and we have different roles. We have the supervisor and participants. Where the supervisor supervises all the connections, supervises the ring, like it says, and the participants taking their place in a ring. It can be switches, but it can also be remote I/O or drives, as long if they support the redundancy, because every device, because they have two ports, do have like a small switch in them.
So in this case, the ring supervisor is essentially the same as the ring manager in PROFINET.
Yeah.
Does the same role.
Exactly.
Checks the integrity of the ring.
Yeah. And how does he do that? It does that by sending beacon frames. This is what it's called in Ethernet IP. Yeah. It's a beacon frame going around the complete ring, and this beacon frame should be received by the supervisor again on another port. And in that way, the supervisor knows that the ring is intact. But for other communications, the ingoing port is blocked. Otherwise, the message will go around forever and ever.
Continuous to go, yes.
And if the devices connected to the network are still sending new messages, it will get fuller and fuller and fuller. So that's why the ring supervisors block its other port.
And it's the only it's only the ring supervisor that has that role within the network.
Yes. So it checks the connectivity and also blocks the port. So the participants on their turn just send through the beacon frames and also just send through all the information. So if we go back to the supervisor, which blocks his other port, the ring participants will not do that. They just send it through and through just as normal. So when we have a breakdown, we have also another possibility where we have the normal supervisor. You have to configure the supervisor. But what if the supervisor itself breaks down? So then you have no supervisor. So then you lose your complete ring redundancy. And for that we have the so-called backup ring supervisor, and that's an automated supervisor. And in that case, every switch in the network can be a supervisor. You don't need to configure that. And what do? All the switches in your network will decide between each other, and it's called like a voting principle with the highest precedence. They decide between each other which one will be the supervisor. And as soon as a supervisor is appointed, and then we can start with the ring redundancy communication.
And in this case, for the backup ring supervisor, there's no configuration. It will all be done automatically.
Yes, yes.
That's very convenient.
Yeah, yeah. The only thing you have to configure is to set the switch to a backup ring supervisor or a fixed supervisor. So that's something you need to do.
Perfect.
Yeah. So if that supervisor will fail, and then the other will take over and decide which one will be the next supervisor. And so we have your continuous communication.
So from the ring topology I've seen that, not only is the ring itself a vulnerability in case it gets cuts, but those managing the ring or having the ring running through them also have to be monitored to ensure that they don't go down and fail.
Yeah, exactly, exactly. So if we have a ring topology and we see that one of the ports of the supervisors is blocked, what you get is that the ring is still aligned. That's a bit strange because we're talking about the ring topology, but in fact it is a line topology, and that is because the end of the line is blocked by the supervisor. So if you cut down this wire, then you have, well, essentially a ring topology.
Yeah, if you open it out, it'll be a ring.
Yeah.
A line.
Yeah, a line topology. So, but now if somewhere in the line something breaks down, we have a second line, and then the ring, one line, will turn into two lines, essentially. So that is very good to see. But a line topology will have some pitfalls in it. First, we have the line depth. So if we put many switches behind each other, the timing is not correct anymore. There you will get some delays, also deviations in your cycle time. That will be jitters. So that is very important to remember that these kinds of things are happening in your line topology. What we also, what you can see here is the line topology, or the line depth, is that we cannot have too much devices behind each other. If we have, let's say, a cycle time that we want to have on 1 millisecond, you can only have 7 devices, 7 switches behind each other.
Wow. Now, I'm just going to jump a little bit ahead here, Fedor.
Yeah.
So my understanding, talking to our support team, like yourself, Elko, Chris, is that this is one of the most common problems you see when you go to troubleshoot sites, that the line depth and the number of devices behind the switches isn't taken into consideration.
Yeah, yeah. Because nobody, or very few people know that if you have a ring topology, it's a line topology. It's
essentially a line,
yeah. And then you get, well, first of all, your line depth. We saw in the previous slide that we have 33 devices in your ring topology, and that means you have 33 devices in a line topology. And with that, you can only reach 8 milliseconds of cycle time, instead of if you want to have 1 or 2 milliseconds. Another thing is with redundant paths is that you also have what you call is the bus loads, line loads. And because at the beginning and at the end you have more or less communication. Later on I will have a slide about that during the diagnostics. So redundant paths also, if you have multiple rings in your network, you need to see where your rings are, and also for your diagnostics.
So, Fedor, when you're looking at your network here, do you monitor the entire network, or do you monitor each ring individually, or do you have a combination of the two?
Yeah, and that's also depending on how you want to do your measurements. You can have an active measurements where your monitor does the communication with all the switches and request all the information from their connections. And you can do that from one point, and the communication will go on the entire network. You can also do so-called passive diagnostics measurements, but that's only on the line where you're communicating. But that gives you much more accuracy in the measurements, so you can measure times like cycle times, reaction times, so you get also more into the protocol-specific information, but that you need to do in each ring individually.
Okay.
Yeah. So, talking about diagnostics, let's dive into this. First we will have the active measurements. And the active measurements, if we look at a ring topology like this, well, that's very easy to do. And you can just connect your Osiris. In this case, it will be Osiris on a Mercury. And you just connect your Osiris to a switch port.
Okay.
Yes?
Also, I'm just going to jump in. So when you're talking about active measurements, this is utilizing SNMP to get data about your network.
Yeah, it's actively requesting the information from all the switches in the network. Well, what the status is of the ports of their part of their network. And
then again, this shows the importance as if you're monitoring with doing active monitoring, you do need managed switches to enable to get the SNMP data out to build a view or insight into your network.
Yeah, unmanaged switches will only send the messages through just like any ordinary switch, but the managed switches can also have multiple or more functionalities built in, and also active communications with other information, just the messages they receive. So this will be the most easiest connection for your analyzing tools. Osiris, again, in this case it will be in a Mercury tablet, but it can also be on your laptop, and also in the form of Atlas, that will be the permanent monitoring tool. Actually, we have here an example.
Yep, the Atlas 2.
Yeah.
Plus, should I say, latest solution that we come out for industrial Ethernet.
Yeah. So in this case, the factory port is connected directly to a switch and gets the information actively from the network.
And that's just scanning the IP range, I assume.
Yes. So what can you get from the Osiris during active diagnostics? Well, all the informations the switches can provide you. That can be the port loads, and that's very important. In industrial Ethernet, you get a lot of information over different ports, and if you have too much information, that would jeopardize the accuracy in your communication. So we need to check that very good. But also things like device failures, configuration errors, port loads, like I said, and also the switches can tell you if their ring is failing or not, their particular connection in their ring.
So it's important that you identify if the ring is about to fail or has failed. So you have that continuous redundancy.
Yeah, and then you know exactly where the ring has failed. So the maintenance guys can go to that location. If you have a factory that's very large and you have many devices in your ring, then you need to know where is the ring failing, instead of checking every switch to see if their lights are red or green.
Just to use the Golden Gate Bridge again as an example, it's like the cables breaking and you're not replacing them. So more and more the cables replaced, more vulnerable the bridge becomes. Your network has the same principle. If that ring fails, your network all of a sudden becomes vulnerable again.
And with the monitoring, you know exactly which cable you need to replace.
Oh, fantastic.
Yeah, because the Golden Bridge is like 300 meters long or even longer.
Yeah, something like that.
That's a lot
of cables to check.
Yeah. So, okay, again, that understanding that the ring is still aligned, and if you look at the port loads at the different locations in your network, you will see that in the beginning or at the end, the port loads are different. And because at the end there's little messages coming, and because it's at the end, but at the beginning you have all the messages going into this line, so you have very high bus load over there.
Okay, so it's really important on your ring that you actually check the load at the start of the ring to see how much it's actually using, and if it's potential to bring down your network. If the network load is really high at the start of the ring, how would we offset that? Would you different type of topology, less devices in the network, that kind of actions?
Yeah, you need to remove devices in the network, and I think the best, easiest way to do, well, the best or easiest, is to divide this ring into two separate rings.
Okay, so if you make the ring smaller, it will reduce the network load and reduce the chance of your network becoming overloaded.
Yeah, the less messages you have, the less the bus load will be.
Okay, perfect.
Yeah. So the other type of diagnostics, that will be the passive diagnostics. And this is another type of diagnostics where you have to break up the line, as you can see here, and then you put a so-called ether tap in between.
I think we have one not connected, but it's just here.
Yeah, it's a good example, the ether tap. It's one on one side you have the USB that's connected to your Osiris, and again, that will be either your laptop or the Mercury tablet.
Yeah.
It can also be connected to the Atlas because the Atlas also has an USB, and it can do the same for you.
So Fedor, why would we, I know we do, it's something we do at Procentec, we heavily promote first step, active monitoring, second step, passive monitoring. In this scenario, why would you say passive diagnostics is so important?
Passive diagnostics is so important because we can go more into the timing aspects of the communication, and also we can go more into the protocol specific part of the communication. Bus loads, port loads are EtherNet in general. But if you look at cycle times or alarms, these are more protocol specific.
Okay, so you need that data to see if it's actually protocol compliant or is adhering to the protocol rules.
Yeah. So you're going a little bit, you dive a little bit more into the communications on itself.
Okay, that's really interesting to know.
Yeah. So here you see some examples for Ethernet IP. And we can see the actual packet interval, that's the cycle time, how often do we get messages. And in the jitter, there's a variation of these messages, so we want to have that compact and accurate as possible. And we can see also the drop packages, connection IDs, what type of connections do we have, and also the information in the messages and also the alarms. So that gives you a good insight of the communication of the Ethernet protocol. And with passive diagnostics of Osiris, we can see also in more accurate the port load, the network load, again the Ethernet errors, statistics, and the trending. And the trending is very important also if we want to have a permanent monitoring and that you can see all the trouble coming.
In particular then the trending, you're able to spot any degradation on your network, build into your scheduled maintenance time and make the necessary repairs.
Yeah. So you can do your scheduled maintenance, your predictive maintenance, and you can see if there's any trouble on the water before it pops up, you can tackle it.
Oh, very interesting. And I'm looking at this here as well, Fedor, and it's very, very similar to PROFINET. So if you know the ring topology principles and the rules for PROFINET, can that be applied to Ethernet IP, or do you still need that additional Ethernet IP knowledge enabled to manage and troubleshoot DLR networks successfully?
It's good to know DLR and also for the PROFINET what protocol they're using. But with Osiris, we try to put all the information in simple words and also together with Delphi to give you in normal language instead of technical language what the problem is and what you need to do.
Oh, perfect. And I know that our support department do say Osiris is salesman proof, so people can troubleshoot with it.
Yeah, exactly. So, having said that, we can go to our last words, and the last word would be, troubleshooting made easy. You already said that there are some steps that we can take. Firstly, we can start with the active measuring, because that's the most easiest one. We take our Osiris connected to any port of a switch, and then we can see the information from your network. And it gives you a lot of information, like duplicate IP addresses. If you're talking about other protocols, there are also device names. Firmware differences is also very important, because you want to have all the devices operating in the same firmware version.
Okay, so that's important just to ensure that you ensure all your devices, they may not have to be the latest firmware version, but they should all be operating on the same firmware.
Yeah. And also interesting to know with our logbox, we can make sure that we have the correct firmware version
the
available.
verified firmware.
Yeah. Okay. Switches information you can find, and also device and port loads, topologies, and line depth. So a lot of good information to do your troubleshooting already. So the next step will be the passively measuring, but the problem is you need to break up the communication and the line. So what you can do is just check the schedule, when can we disrupt the network and do our measurements. What you also can do is put a so-called ether mirror in, and with this ether mirror you have a permanent connection open for you for your ether tab.
Okay, so this is fundamentally a measuring point that allows you to get passive monitoring data without disturbing or breaking up your network.
Exactly. And you have all the benefits of the timing, jitters and update times, alarms, and protocol-specific information.
I do know our support department love when our customers have EtherMirror because it means they don't have to wait around all day until they shut down the machine to get passive monitoring data.
Yeah, and even sometimes you go to a customer and you say, oh, sorry, I need to break up the connection, and they say, well, it's not possible because we're producing. And I say, yeah, when is it possible? Can you schedule something? No, sorry, not today. And then you have to drive home. So without doing any work, well, you have to go home again. Luckily, we get paid, but they have to pay, and that's for them.
They have to call you back in the next day as well, and that can be offset by utilizing the EtherMirror as a measuring point.
Yeah, and it can be the next day or next week or next month, depending on their schedule. But in the meantime, they're having their problems. So if you put a so-called EtherMirror already in a network during the installation installment, that will help you out.
It's a really smart idea to ensure continuous operations.
Yeah, exactly. So, given all that, always, well, the best way also to start troubleshooting is just listening to your customer. What do they expect, what do they see, what do they hear, everything. And that will give you a lot of information how to start your troubleshooting. Okay, so given that, well, thank you for this talk.
Yeah, it's been really interesting, Fedor. I'm keen to see this operating in the field. Thank you for joining us today. And I do believe if anybody has any questions on network topologies, they can reach out to you at support@procentec.com.
Yes.
Or they can send emails into training@procentec.com, and Fedor will give you any additional support that you need in terms of designing ring topologies or advising on how to do it, but also on how to monitor, manage, and troubleshoot these topologies and networks. So Fedor, thank you for joining.
Yeah. Thanks for your attention.
I'm sure we'll see each other again very soon.
Yeah.
Cheers. Thanks, Fedor.
Cheers.